Okay, so in this video I'm gonna show you how to create this analog clock using the Arduino UNO and this OLED display. And as you can read down here, this display is sized 128 by 128 pixels. And because it's using the I2C connection, I'm only using 4 wires to connect the display to the Arduino, but more about that later. For now, I want to start with some kind of design. And for a project like this, I usually start in some kind of graphic editor, for example Photopea, which is a free online editing tool similar to Photoshop, and then select the pencil tool and start drawing some pixels. But I will not do this today because I want everything to be drawn using the standard graphic primitives like lines, pixels, and circles. And we will not be using any images in our project, with one exception, and that is showing the logo of sponsor of today's video, which is PCBWay. And not only you can get PCBs, but also other manufacturing services like 3D printing or CNC machining, all for a very good price. Actually, if you use the link down in the description of today's video, you can get 10 PCBs for free, only paying for shipping. So thank you PCBWay, and let's get back to our project. So as I've told you already, we don't need to draw any images today, so we can skip this step and instead talk about how to draw those primitives or how to actually calculate the positions of those primitives. Let's say that this is our display and we want to draw one pixel, for example the one on top, this one. And so the way you draw it is we define the position being the X position, which is the vertical distance, and the Y position, which is the horizontal distance. But we can also think about this point in relationship to the origin, which might be placed in the middle. And instead of using the X and Y position, we can define the angle to the origin, so some kind of angle, and the distance to the origin. And that's quite useful because if you think about all those little points, they have the same distance to the center, to the origin, only the angle is changing. And since we want to draw 60 different points around the whole circle, we can easily calculate that the angle increment is 6 degrees. However, we cannot tell Arduino to draw the pixel on the position, angle and distance. We still need to provide the X and Y values. And since the X and Y is called the Cartesian coordinate system and the angle and the distance is called the polar coordinate system, we need to convert from the polar coordinate system into the Cartesian coordinate system. And for that, there is this formula. So the X equals R times cosine of the angle. So the R is the distance and Y equals R times sine of the angle. Let's jump to the WOKWI, which is a free online Arduino emulator, and let's try to draw something on the display. And this is the simplest possible sketch for using the u8g2 library, which is the library that we are using for drawing on the display. We first set the correct display, which is this one. And unfortunately for the simulation, the only display that we can use is this 128 by 64 pixels. So it's half the resolution of our final display. So at some point we will only see half of our design, but I guess that's better than not seeing anything. Then inside the setup, we need to call the u8g2 begin function. And then inside the loop, we need to call this while loop, and that's because we are using number 1 in the constructor, which means update the display by pages. So we need to first draw the first page function and then do the drawing inside this loop and then call the while next page to go over all the pages. If you are not sure what all this means, I would suggest you to watch my other videos where I go into quite a lot of details on how to set up a project using the Arduino UNO and the OLED display. Let's draw our pixel by calling the draw pixel function, which only requires the X and Y position. So I'll just copy draw pixel into our loop and say u8g2.drawPixel on some position, for example 6432, which will be in the middle of the screen. And it might also be a good idea to call the setDrawColor function to set the color to be white. So I'll just copy this one and again say u8g2.setDrawColor to 1, which is a white color, and do this before drawing the pixel. And now as I restart the simulation, I should see a very tiny pixel in the middle of the screen, which seems to be the case. Let's set the position using the polar coordinate system, that is using the angle and the distance, the radius, and for that I will create 2 more variables. One will be the X position, and that will be, as the Wikipedia says, cosine of the angle. Let's just say the angle is 0 times the radius, for example 30 pixels. And the angle has to be provided in radians, so I'll convert it from degrees to radians using the radians function. And I'll do the similar thing for the Y position. So the Y position will be the sine function of the angle times the radius. Now this expects that the origin is on the left top, but we want to have the origin in the middle. So I'll add the 64, which is the half of the width, and 32 for the Y, which is half of the height of the display. And then of course I will draw the pixel on the position X position and Y position. And now we have the pixel displayed on a different position, but it will be nice if the 0 position, so 0 angle position, will be up on top. And for that we can try to switch the cosine and the sine function. So for X let's use sine function, and for Y let's use cosine function instead. And now we are getting somewhere because now the pixel is on the bottom, but we still want it on the top. So what we can do is we can switch the cosine function to minus cosine, and indeed now the pixel is on the top. Let's draw more of those pixels, for example 60 to be 1 for every second. So I'll do this inside the loop, saying for integer y equals 0, while the I is smaller than 60, I will increase it by 1. Let's move the draw color outside of our loop. And for the angle, let's use I times 6, because 300 by 60 divided by 60 is of course 6. Obviously with the limited resolution it might be hard to create a nice looking circle, but maybe rounding those values from floats to integer might help a little bit. Okay, so maybe this looks a little bit better. From now on, let's treat our project as if we were using the final display, which is 128 by 128 pixels, but obviously since this display is only 128 by 64 pixels, we will only see half of the screen, but that should be probably fine. So let's start with drawing this circle in the final size, and for that I will create two more variables. First of this will be the center X position, that will be the center of the screen, in this case 64 pixels, and center Y, and that will be the Y center of the screen, again that will also be 64 pixels. And let's actually create a new function for drawing all those individual dots, and let's call it draw background. We don't need to provide any parameters. I will just copy this section into our draw background function, and inside the loop I will call the draw background function. So draw background without any parameters, and I want to change the function slightly. First thing is to use the center X for the X origin and center Y for the Y origin, and let's make the circle much bigger, for example setting the radius to 60 pixels. The biggest value that we can use is 64, but I want to draw one more circle around the whole display, so let's just keep it a little bit smaller. And as expected, we see the top half of our clock display. So let's actually draw this full screen circle around the whole display. And for that, we will use the draw circle function. Now, the important part is that the diameter of the circle is 2 times radius plus 1. So we cannot use 64 for the radius because it will end up the circle being 1 pixel outside of our screen. So I'll copy this example, paste it in here into our draw background function, set the X position to be center X and Y position to be center Y. And since we cannot use 64 for the radius, we will go with 63 instead. And now we have the circle and those individual dots. Obviously we still only see half of the screen. So let's test it on the real Arduino and the real display. For that, let's copy the code, run the Arduino IDE and paste the code in here. If you haven't used the u8g2 library before, you have to go to libraries, type in u8g2 and click the install button. Then of course select the correct board, which in my case is the Arduino UNO. And we also need to set the correct display, because the one that we are using is not this SSD1306, it's actually the SH1107. So let's jump into the u8g documentation and search for SH1107, which will be 128 by 128 pixels. And we are looking for the I2C connection, so this down here seems to be the I2C connection. I want the hardware I2C connection, and this one means draw by individual pages, which is the same case as we are using in our sketch. So I will just copy this piece of code into the Arduino IDE, comment out this one, and set this to also be the u8g2. Rotation should be R0, and I don't have any reset button or clock and data because I'm using the default I2C line, so I can just delete those parts and comment out this comment. Let's upload this to Arduino and see what happens. And we see the circle and the individual dots, but somehow this is not on the correct position. It looks like everything is offset to the right side by some number of pixels. And upon some searching, I did find out that it has to be set in the library code. Inside the u8g2 library installation folder, you have to search for the SH1107.c file and then search for the default X offset. And as you can see in here, it's being set to 96 pixels because most likely the creator of the library was using a display that has this set to 96, but our display is most likely 0. So I'll change it to 0 and maybe in other places as well, because I'm not quite sure which constructor I'm using. So just to be sure, I will set it to 0 here and here as well, and that should be enough. So I will save the file, go to the Arduino IDE and try to upload it one more time. And indeed, now the circle is being centered on the display and everything looks like it should be looking. So let's move to the next part. We will finish the background first with those digits and bigger tick marks, and then move to the fun stuff, which will be drawing those individual needles, those individual hands. It might also be a good idea to copy the constructor of the final display into our WOKWI sketch and comment it out for the WOKWI project. The next step is drawing those big tick marks, and since we already know how to draw those small dots, it will be very simple. We just need to calculate the position of the starting point and the ending point and then draw the line in between those 2 points. Let's do exactly that. So inside our code, I will expand our draw background function with drawing the big tick marks. And what I will also do is I'll define the X position and the Y position outside of the drawing, because I want to reuse those variables also for the tick marks. And I will create 2 more variables. One will be the X position 2 and the Y position 2. And I can probably also copy this whole for loop, but I will make some slight changes. The first thing is that I want to draw less tick marks. So I'll set the I only up to 12. which means that I need to set the angle as I times 30. And let's also set the radius to be slightly smaller, for example 54 pixels, and also calculate the second set of points that will be x position 2 and y position 2, and the only change that we will do is to set the smaller radius, for example 46. And then instead of drawing the pixel, we want to draw a line, so in the documentation I will search for the drawLine function and just copy this example, and it's as simple as it could be, drawing the line from the x and y position to the inner x and y position. So copy this one into our code and draw it from the x position and y position to x position 2 and y position 2. And hopefully that should be enough to draw our tick marks, which seems to be the case. However, I don't want to draw all the tick marks, because if I open the preview, you can see that the tick marks are not being displayed on all the positions, because I want to show some labels. And the counter I goes from 0 up to 11. So I can use the modulo function with the divisor of 3, and that will give me numbers 0, 1, 2, 0, 1, 2, and so on. And I don't want to draw the tick marks when the modulus equals 0. So let's add a simple if statement saying that if the modulo of the value I, so I modulo 3, does not equal 0, in that case I will draw the tick marks. And we can at least see that the tick marks is indeed not being drawn on the position of number 12. So let's actually add those labels. Now to draw some label, we need some kind of font, and there are actually so many fonts to choose from for the u8g2 library that you can spend hours just deciding which might be the right font. I went with the font called u8g2 font 8x13. Now the B stands for bold and the N stands for numbers only. You can select also the R, which is the reduced font, or the F, which stands for full font. So in our code, I will call the setFont function with the name of the font, and after that we will use a function called the drawString, which will draw a string on a certain position. So I'll just copy this into our code and change the text to be 12, and then copy and paste this code 3 more times, because I want to also draw number 3, 6, and 9. Now for the actual positions, you can of course use some functions to calculate properly the center of the text. I'll just hard code these values because I already know what those values should be. So all that's left to do is to restart the simulation and hopefully see those digits. And I think that this might be enough for the background part. Let's just quickly see how it looks on the real display. And I think it looks quite nice. So let's move to drawing those individual needles, those individual hands. And we will start with the second hand, because this one is the easiest one to draw. We only need to know the positions of the 2 points, this one being the first point and the second one being this point, and then draw a line in between those 2 points. So it will be very similar to drawing those individual tick marks, but in addition we will also draw this small circle on the position of the second point. Let's create a new function called drawHandFin, and this time I will need some values. I will need the hand angle. I also need to know the length of the hand, and I need to split it into 2 different values. One will be the hand length long, and the second one will be the length short. And I will actually borrow a lot of pieces from the previous code for drawing the background, so all those variables should be there as well. And I want to also calculate those in the very similar manner. So I'll just copy this piece of code for calculating those positions based on the angle, but this time the angle will be defined by the hand angle. So I'll just use the hand angle in all 4 lines. One radius will be the hand length long, and the second one will be the hand length short. And I also want the second point to be rotated by 180 degrees to be on the opposite side of the center, and then use the very same function to draw a line, which in this case will be the second hand. Now before adding the circle, let's just quickly test this, and for that we need to call this function with some variables. So I'll just copy this hand drawn fin. For the angle, let's just use for example 45. And for the sizes, I've used 56 and 24. And we see something that looks like a second hand. Let's change the angle to at 180 degrees so we can see the second half of the needle, because for that one we want to draw this small circle. So inside the function for drawing the hand, I will just copy this drawCircle function, and the position will be the x position 2 and y position 2, and radius will be something very small, for example only 3. However, because we draw the circle and the line from the same point, you can see it looks quite different from our preview where there was no intersection. And we can fix this in a few different ways. I think that the quickest one will be to draw another black circle that will cover the line. So before drawing this circle, let's draw a filled circle, which is called drawDisk. I will use the same parameters, but before drawing this circle, I want to change the color to be black. So I'll call this u8g_drawColor function and set the value to 0 for the black color, and then change it back to 1 for the white color for drawing the outline. And now it looks much better. And this is how the second hand looks on the real display. So we can move on to drawing the other hands, being the hour hand and the minute hand, and those are probably the most complicated part of the project. And that's simply because you cannot draw a rotated rounded rectangle with some built-in function. So we have to split the needle into individual graphics primitives that we can actually draw with the u8g2 function. And if you take a closer look, this looks like a circle, as well as this part looks like a circle, and we know how to draw filled circles already, so we just need to get those 2 points and draw those 2 circles, and we can actually use this point to draw the line to the origin that will form at least the basics of the needle. Let's copy the whole draw hand fin function and rename this to draw hand bolt. And we need one more property, which will be the radius of those circles. So let's just call those hand dot size. And we need to make a few changes. So we don't need to add 182 second angle because everything should be on the same side. And instead of drawing the line from the first position to the second position, we want to draw a line from the center. So center X and center Y to the X position and Y position. And then draw a filled circle on the first position, so draw disk on the position X, X position and Y position, with the radius being the hand dot size, and one more disk on the second position, so X position 2 and Y position 2 with the same radius. Let's quickly try to draw the needle to see how it looks like. I will hide the second hand and draw the hand bolt. This might be, for example, the minute hand. Angle will be 45. And for the sizes, I believe I used 48 and 15, with the diameter of the circle being 2. Let's restart the simulation. And we see part of our needle, and we actually don't need to draw the line all the way to the second point. We can end on the first point instead. So something like this should be enough. Now, in between those two circles, it might make sense to draw a rotated rectangle, but that's something that we cannot draw using the u8g2 library. But what we can draw is a filled triangle using the draw triangle function, where you specify 3 points and it will draw a triangle. So in our case, we'll draw a first rectangle like this. So from those 3 points, we'll connect those 3 points, and the second triangle like this. And while we know what's the center position of this circle, we don't know what are the positions of those 2 points, but that could be easily calculated. We just need to take the center of the circle, which will be this point, and then calculate the new point based on the angle. So this will be the angle of the hand. We will just add 90 to it, so it will be the new angle, and the radius, which will be the size of the circle itself, and this will give us a new point. And instead of calculating this as the absolute position, let's store this as the offset, as the X and Y offset from the center of the circle. I will add 2 more variables. One will be the triangle X offset, and the second one will of course be triangle Y offset, and calculate those 2 offsets. So the triangle X offset will be calculated as the sine function of the angle in radians, and that will be the hand angle plus 90 degrees, and the radius will be the hand dot size, and then I will round everything. The Y offset will be very similar, except now of course we will use the minus cosine function with the same parameter. So the angle is hand angle plus 90 and the size is hand dot size. So now we take one position, for example the X position and the Y position, and apply the X and Y offset, which will give us this point, and then we will subtract the X and Y offset, which will give us this point. Now we'll take the second position, which is X position 2 and Y position 2, and for example add the same X and Y offset, and we will get the third point, which should be enough to draw the triangle. So this will be triangle from this point to that point to this point. And then we will do the same thing, except we will of course use the second position. Let's copy the draw triangle function from the u8g2 documentation and plug in the right values. So again, we will start with X position plus the X offset, then the Y position plus the Y offset. The second point is very similar, except now we are subtracting this offset, and the third value is also similar, but now we are adding this offset, but using a second point, which is X position 2 and Y position 2. And as I restart the simulation, we see something that resembles a triangle. So let's draw a second one. This time the first 2 points will be based on the second position, so X position 2, and the last point will be X position, Y position 2, and the last point will be Y position, and the last point should be minus the offset. And now we have something that looks like the needle from our preview. Now for some of those angles it looks better for the arrow one. So for example, if I change it to 15, those triangles look more connected to the circles compared to seeing the needle in the 45-degree angle, but I still think that it looks nice. And this is how the minute hand looks on the real display. There is one last thing left to draw, and that's this circle in the middle, and for that we'll reuse the code for drawing the second hand. So in the main loop I will just paste this code, but I will draw both the disk and the circle on the position center X and center Y, and make this slightly bigger, so for example 4 pixels in the diameter. And you can see that half of the circle covering the hand is there. So we have all the drawing functions, but we are not drawing all the individual hands, so let's do that now. I will create 3 new variables, being the time seconds, then of course time minutes, and also time hours. And then inside our main loop, let's increase the time seconds, and if the time seconds is bigger or equals 60, we will set it back to 0, but also increase time minutes. And similarly, if the time minutes is bigger or equals 60, we will set it to 0, and we will increase time hours. And finally, if the time hours is bigger or equal 12, we will reset it back to 0. Then inside the draw function, we will draw the second hand, where the angle will be time seconds multiplied by 6. Then the minute hand, the time will be time minutes, minutes multiplied again by 6. And finally the hour hand. The time will be time hours, but this time it will be multiplied by 30 because we only have 12 hours in a 360 circle. And the size of the hour hand should be slightly smaller, for example 32 pixels. And as I restart the simulation, you should see the animated analog clock, with the second hand of course ticking way too fast, but that's mainly for testing purposes. So I think it looks great. Let's see how it runs and looks on the real Arduino with a bigger display. And it looks even better. You will also notice that it's slightly slower, and that's because now we have to update 128 by 120 pixels compared to half the resolution inside the WOKWI emulator, so it just takes a little bit more time. Obviously it's also showing some random time and the second hand is not ticking every second, but that's something for the next time to fix. I hope you've learned something new today. If you have any questions or comments, please put those down in the comment section. Thank you very much for watching and I hope to see you next time. Thanks and bye.